So now we are in the practice set on page 5, looking at number 25. So we've got 3x over 5 divided by x over 3 plus 1 over x. So operation-wise, what do we have in this problem? Division and addition. So because of the addition on the bottom, we will need to find an LCD of just the bottom. So large picture-wise, what we are looking at here is a complex fraction because we have multiple fractions stacked on top of each other. So this is going to be my top fraction. Now, remember we said with complex fractions, we should try to simplify the top first. Is there anything to do with 3x over 5? Can I simplify it or factor it or anything? Nope. So 3x over 5 is already simplified. Now, for the bottom of this fraction, we have addition. And anytime we have addition, subtraction, or an equal sign, we have to find the LCD. So looking at my denominators, we've got 3 and we've got x. Can I factor tree 3? No. Can I factor tree x? No. So the greatest amount of 3's we have in one term is 1, 3. And the greatest amount of x's we have in one term is 3. Now, am I going to multiply through by the LCD to blow up those fractions? No, because I don't have this side to multiply by the LCD and that side to multiply by the LCD. If I just multiply through by the denominators, we are going to be completely changing the values of the fractions. So we are going to need to multiply by a creative form of 1. So what am I going to multiply x over 3 by? X over x. So we're multiplying by 1. What are we going to multiply 1 over x by? 3 over 3. So now, in our denominator, we'll have x squared over 3x plus 3 over 3x. So always remember to multiply the top and the bottom by that missing part of the LCD. So now, we have a common denominator. What next? We add them. What do we add? Just the numerators. And can I actually add x squared to 3? No. So I end up getting x squared plus 3 all over 3x. And if you're like, well, that didn't really do much for us, did it, Cairo? Well, it did change this from 2 fractions on the bottom to 1 fraction on the bottom. And that is our goal for these complex fractions, is to get it down to 1 fraction. So large picture-wise, we are now ready to take the top fraction, this, divided by the simplified bottom fraction, which is this. This is the point, now that I have just 2 fractions and then the big large one, is I do keep, change, flip. So I'm going to keep the top fraction. So 3x over 5. I am going to change the operation. Instead of dividing, what are we going to do? Multiply. So we change the division to multiplication. And then flip. We reciprocalize the bottom fraction. So the 3x will be on the top, and the x squared plus 3 will be on the bottom. Trap, trap. So now that it's multiplication, we can slide these together, joining them with multiplication between the top and the bottom. Is there anything that I can cross simplify? That's a no. Kind of unsatisfying, but it is what it is. So 3x times 3x gives us 9x squared. And then 5x squared plus 3 on the bottom. We do not have to distribute it because leaving it in factored form is considered best form. And our goal has been achieved. We got it down to 1 fraction. That's the answer. So that was one problem I wanted to go over with you guys. The other question is on the back of this page. Let's go ahead and look at number 32. Same type of problem, but this one has more steps. So if I say identify the operations, we've got addition on the top. Addition, we got to find a common denominator. Addition on the bottom, ooh, we're going to have to find a common denominator there too. And then we've got that large dividing bar. So this is a complex fraction. So we're going to have to simplify the top first by adding those fractions together, the bottom next by adding those fractions together, and then keep, change, flip. So let's go ahead and see if we can find a common denominator for the top. So the greatest amount of x minus 3's we have is x minus 3. X squared minus 9, is that its own factor? Difference of squares. So I'm going to factor that as x plus 3 and x minus 3. And check it out. We've got difference of squares again on the bottom. So x plus 3, x minus 3. So when I go to find those LCDs of both the top and the bottom, the greatest amount of x minus 3's we have is 1x minus 3. The greatest amount of x plus 3's we have is 1x plus 3. So what's our LCD of both the top and the bottom? X plus 3, x minus 3. Or x minus 3, x plus 3. Remember, the order does not matter. Using the LCD and creative forms of 1, I want you to try to simplify the top. And folks, if you're already done with this page, use this time to be working on other problems. But this is homework work time, and there is one due tonight and one due on Sunday.
Sunday?
Mm-hmm. Do we need a creative form of 1 for the second fraction? No. No. So now they have a common denominator after we distribute that 2 to both of those. So we add the tops together. And we do have some like terms. So 2x plus 3x is 5x plus 6. And this is all over x plus 3, x minus 3. And I'm going to go ahead and look at that 5x plus 6. Do I have a GCF? Remember from the homework quiz yesterday, those GCFs are rather a pain, so always be on the radar for those, especially in your binomials. So no GCF there, so I can trap that top. And that entire thing is my simplified version of the top of this big old complex fraction. Now on the bottom, we have a similar setup. This one will not need a creative form of 1 since it already has the LCD. But the one on the left, what time is lunch? 15. But the other fraction is going to need x minus 3 over x minus 3. See if you can finish the problem from here. Find what the bottom is equal to by adding those two fractions together and then keep, change, flip.
5x plus 6 is
Oh,
yeah,
that's right.
5x plus 6 over 7x minus 3.
We know. Can you shape that over here? Can you shape that X over 5x?
Because if you
It's 5 times.
no, because we can't take it's 5 out of 6. Right?
Because the X is 5 times X.
I have no idea. Yeah, because when you times like it says there's 5x plus 6.
Yeah, they're mine.
So for your bottom fraction, you should have gotten 7x minus 9, which is not factorable, no GC up there, over that x plus 3 over x minus 3. Now at this point, we've got the top divided by the bottom, so we keep the top. We change the division to multiplication, and then we flip the bottom fraction. So keep 5x plus 6 over x plus 3, x minus 3. Change to multiplication and flip. So this fraction, now x plus 3, x minus 3 is on the top. 7x minus 9 is on the bottom. So cross-simplifying wise, goodbye to the x plus 3's and the x minus 3, since these are all joined by multiplication now. So the only thing I have left is the 5x plus 6 and the 7x minus 9. And that is our final simplified answer. Trap, 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 trap. How did we do on that one? I think I will turn you loose then on number 33. So if you haven't done 33 already.
Is the LCD 2x plus 3? Miss Karen, would the LCD for 33 for the top two fractions be 2x plus 3?
It'd be 2x plus 3 times x plus 1.
Oh, it's both of them?
Yep, it's both of them.
Oh, because they're binomial.
Page 78 on Canvas.
Oh, is it not up yet? Yes, I can. Thank you.
How?
So it brings
2x plus 3 times x plus 1.
So it's like so she'd get some to 6, and then there's going to be
You have
squared
to
to
calculate
60
2x plus
squared
3.
here.
The 2x?
And the only restriction you have on
No,
this
so-
that
so
is
L-
0.
3 over 2x plus 3 you times by x over x plus 1 over x plus 1. That'd be like.
So we've got another complex fraction. I would start by floating that negative up with the x. 2x plus 3 can't be canceled. Trap, trap. Neither can the x plus 1. So the LCD of both the top and the bottom is 2x plus 3 and x plus 1. So I will need to multiply this one, x plus 1 over x plus 1. We multiply by what it's missing to get to the LCD. And this one by 2x plus 3, or 2x plus 3. On the bottom, x plus 1. Now remember, this one's a little bit nastier. You slide the denominators together, leaving them in factored form, but you distribute the top. So I'm going to do 3 times x, 3 times 1, but slide the denominators together. Distribute the x, and then slide the denominators. So I'm going to show a little less work for this and show my distribution and adding those fractions together in one step. For my top fraction, I'm going to get 3x plus 3, and then distributing that, I'll get a negative 2x squared, a negative 3x, all over the common denominator. So I distributed and then added the tops together in one step. And then we can simplify it. Now, when I simplify, I would put it in that quadratic order, negative 2x squared, and then the 3x's cancel. 3x and negative 3x cancel. We get plus 3. And that's all over 2x plus 3 and x plus 1. So that's our simplified answer for the top. Take it from here to do the bottom and keep, change, flip. Mm-hmm.
So when you get 4x squared plus 11x plus 5 for your bottom fraction, do you have to like factor that using the x method?
You do need to try to factor it.
It doesn't.
And if it doesn't work, then you're stuck with it.
That means 4 factored, and then you can go like to keep change flip. Like if it doesn't.
Yep, you can still keep, change, flip.
Alright, then okay.
So folks, that's what your bottom fraction looks like. And then when we keep, change, flip, it looks something like this. Now we can definitely cross those off. But for proper form, we should try to factor this. So let's go ahead and try to find factors of 4x squared, 2x and 2x, 1 and 5. That gives me 10x and 2x, which is really close, but it doesn't work. Then we try 4 and 1. 20x and 1x, nope. We try 1 and 4, and that gives us 5x and 4x, which doesn't work either. So you should always try to factor it in case it does lead to more simplifying, but when it doesn't, you just trap it in parentheses, and that's your final answer. So negative 2x squared plus 3 all over 4x squared plus 11x plus 5. So how the final answer looks really depends on what you started with, what your LCD is. Sometimes you'll be able to simplify more, and sometimes you won't. So folks, I think that's where we will stop before we go to lunch.